Yeah, thanks. Welcome again. Today we are going to solve a very, very important materials based on the different questions of the concave mirror. So there is no doubt on that. Last time we covered a lot of material. So today we want to keep this momentum and trying to understand more about the concave mirror, the different part about the how we can find the radius of curvature, the focal length, also the magnification, the image height, as well as object distance, image distance. There is no doubt on that. So the lesson of today is based on how we can deal with those important materials. So let's start by solving different questions. The first question is that what is the focal length of the concave mirror whose radius of curvature is 20 centimeter? So this is the first equation. What is the focal length of the concave mirror? This is the first equation. Uh, First equation, what is the focal length? What is the focal length? What is the focal length of concave mirror? What is the focal length of the concave mirror whose radius of curvature, radius of curvature, radius of curvature uh, is 20 centimeter. So this is a very, very important question. We're going to start with these questions. Question number one there, what is the focal length of the concave mirror whose radius of curvature is almost 20 centimeter? So what is that? I give you almost 30 seconds to comment your important answers so as you can check whether you are correct or not. Whether you can check yourself we are quality or not. Thanks for those who continue to comment. We are going to confirm soon whether your answer is correct or not. You are going to confirm soon whether your answer is correct or not. Remember that our questions are today based on the part of right, particularly or subtopic of the concave mirror question. So today we are going to solve different questions based on the concave mirror. So check question number one there. What is the focal length of the concave mirror whose radius of curvature is almost 20, 20 centimeter. Thanks for those who continue to comment and to come out with their important answers. Now let's do together to confirm your answer a solution data given, a solution data given, solution data given, solution data given. We have given radius of curvature represented by capital R, which is 20 centimeter. What will be the focal length? That is a very, very important concept today. We will call the formula from the focal length from focal length is equal to radius of curvature divided by 2. That is how we said last time. The focal length is given as radius of curvature divided by 2. So we take the focal length is equal to 20 divided by 20 centimeter divided by 2. Divided by 2. So finally, you can see now the focal length is almost 10, 10 centimeter. Thanks and congratulations. A lot of committee comments 10 centimeter. They are almost correct about this important material. So what is very, very important in this party, we are supposed to recall the formula and to know that we have given different datas. We have given radius of curvature. This radius of curvature, normally denoted by capital R. So solutions are data given. Radius of curvature denoted by capital R is equal to 20 centimeter. Do you see that? What will be the focal length? Focal length denoted by small f. The small f, what is it? Now from the formula, this is very, very important formula we are supposed to be familiar with. if you want to find it, the focal length is equal to radius of curvature divided by 2. So the focal length is equal now to radius of curvature, which is 20 centimeter divided by 2. So finally, you can get the focal length is given as the 10, almost 10 centimeter. So congratulations a lot for those who comment 10 centimeter. Let's keep this momentum. Now let's move to the question number 2. Question number 2 say a concave mirror has a focal length of 15 centimeter. What is the radius of curvature? A concave mirror has a focal length of 15 centimeter. This is question number 2. The question number 2 now, we say a concave mirror, a concave mirror has a focal length, of 15 centimeter. What is the radius of curvature? What is the radius of curvature? What is the radius of curvature? So that is your turn now. Try. I give you almost 30 seconds to come out with the important answers based on the question number 2 there. You're told that a concave mirror has a radius as a focal length of 15 centimeter. What is the radius of curvature? So that is your turn now. Try for almost 30 seconds to you to tell us what will be the value of the radius of curvature of this concave mirror. Thanks for those who continue to comment. Thanks for those who continue to comment. They are trying to come out with the important answers. And soon we are going to confirm and to check your answers whether it is correct or not. Thanks for those who continue to comment. Thanks. And we are going to confirm soon after 30 seconds to you. So there is no doubt on that. There is no doubt on that. Thanks. Now let's do together. 30 seconds is over to you. Let's do together. So in this question, you have solution data given. Solution data given. We have solution data given. In this question, we have given focal length denoted by small f is equal to 15 centimeter. What will be the radius of curvature? What will be the radius of curvature? Now here we should recall the formula. We will know the focal length from focal length is equal to radius of curvature divided by 2. That is very, very important formula. So if you wanted the radius of curvature now, radius of curvature, it will be 2 times focal length. 2 times focal length. Now radius of curvature is equal to 2 times 15 centimeter. So finally, you can get the radius of curvature. The radius of curvature is almost 30 centimeter. Congratulations a lot who commented 30 centimeter. You are almost correct. And this shows that you are more competent in physics. What is very, very important in this question number 2, which is say a concave mirror has a focal length of 15 centimeter. What is the radius of curvature? A solution data given, we have given the focal length, which is almost 15 centimeter. 15 centimeter is equal to here, which is denoted by normal focal length denoted by small f. So small f, which is focal length, is equal to 15 centimeter. The radius of curvature denoted by capital R. So this what will be what? Now from the formula, focal length is equal to radius of curvature divided by 2. So if you want to get the radius of curvature, now it will be is equal to 2 times the focal length. So it will be 2 times focal length, which is 15 centimeter. Finally, you can get the radius of curvature is equal to 30 centimeter. Congratulations a lot of those who comment that. You are more competent in physics. Now let's keep this momentum moving to the question number 3. Question number 3 today, which is say that question number 3 is very, very important to be noted about question number 3. The question number 3 say, state the mirror formula. State the mirror formula. Question number 3. Question number 3 say, state the mirror formula. State the mirror formula. So that is very, very interesting and important question today. It is question number 3. There is no doubt on that. Thanks for those who continue to be together in these important materials. Now, question number 3, you may see yourself there. State the mirror formula. 30 seconds to you to come out with these important answers based on these important materials. Remember, we are talking on the part of light, and particularly or specifically, we are talking about the concave mirror questions. So today we are going to solve a very, very important questions based on the plane, the concave mirror. So there is no doubt on that. Thanks for those who continue to comment and to come out with the important answers based on this part of light, the concave mirror, among of the types of the curved mirrors. We have this a concave mirror, and also we have convex mirror. So today we are dealing particular or in detail on the concave mirror. Thanks for those who continue to comment to set the mirror formula, and soon we are going to confirm your answers whether it is correct or not. There is no doubt on that. Today you are trying to provide great participations, and congratulations. The way you are participating is so much appreciated. Thanks for those who continue to comment. Now, the mirror formula, it is simple. The mirror formula, you remember, mirror formula is equal to 1 over f is equal to 1 over v plus 1 over u. So that is the mirror. That is the mirror formula. That is the mirror formula. But if you want to consider the letters, you should do something like this. 1 over f is equal to 1 over u plus 1 over v, if you consider the letters, because v is starting before, u starting before v, so there is no doubt of that. Thanks for those who continue to comment, and there is no doubt on that. Congratulations a lot for those who try to point out and set the mirror formula as 1 over f is equal to 1 over u plus 1 over v. So this is the mirror formula. Everyone is supposed to know. This is very, very important formula, which is almost governing all types of mirrors based on this formula. 1 over f is equal to 1 over u plus 1 over v. So it is very, very interesting point. Congratulations a lot for those who try to point a correct answer. There is no doubt on that, and this proves that you are more competent in physics. So let's keep this momentum. Continue now. Question number, the question number 4 now. So there is no doubt on that. There is no doubt. Now let's move on with the question number 4 now. The question number 4, which is state that question number 4, an object is 30 centimeter from concave mirror of a focal length 10 centimeter. Find the image distance. An object is 30 centimeter from concave mirror of a focal length almost 10 centimeter. So this is another important question. Set this important question. So it is very, very interesting. This important question, an object. The question number 4, which say an object is the 30 centimeter from a concave, from a concave mirror, of focal length, 10 centimeter. Find the image distance. Find the image distance. So that is very, very important questions, which will be question number the question number 4 now. Question number 4, an object is 30 centimeter from a concave mirror of the focal length almost 10 centimeter. Find the image distance. So it is very, very interesting questions. I give you almost 30 seconds to come out with the very, very important answers on this part. Thanks for those who continue to comment and trying to come out with the important answers based on these important materials. I remember it is right now on the part of the concave mirrors questions. Today we are dealing with these important materials. Thanks for those who continue to comment. And soon you are going to confirm your answers if it is correct or not. So there is no doubt on that. There is no doubt on that. Now, let's do together these important materials. And what is very, very important is to know the data which you have been given. Now, solution data given. We have solution data given. We have solution data given. We have solution data given. This question we have given the object distance, which is 30 centimeter. And also you have given the focal length, which is almost 10 centimeter. What will be the image distance, which is denoted by V? Now, what is very, very important is to recall the formula, the Miller formula. So from the Miller formula, Miller formula say 1 over F is equal to 1 over U plus 1 over V. Do you see that? So this is how we can do. So there is no doubt on that. Now, we can say now it will be 1 over 10 is equal to 1 over 30 plus 1 over V. Now 1 over V, you may see yourself, it goes, if this 1 over 30 goes in another side, if it is goes in another side, now it will be what? It will be 1 over 10 minus 1 over 30. So that is very, very important question we can do in these important materials. So if that is the case now, we can find the LCM there. Now it will be 1 over V is equal to 30 is equal to 30. Now 30 divided by 10, we get almost 3. So 3 times 1, we get 3 minus, now we have 30 divided by 30, we get 1. 1 times 1 is equal to 1. So it is 1 here. So it will be is equal to almost 2 over 30. 2 over 30. Now it will be now 1 over V is equal to 2 over 30. So if you cross multiplication, finally you can get now V is equal to almost 30 divided by 2. So the image distance is equal to 15 centimeter. It's equal to almost 15 centimeter. So there is no doubt on that. Now what is very, very important in this question is to identify the data which you have been given. So solution data given. They have given an object is almost 30 centimeter from the concave mirror. So this is image distance, of course. I mean object distance. So object distance is equal to 30 centimeter. And the focal length also you have given almost almost 10 centimeter. So what will be the image distance? So from the formula, which is Miller formula, 1 over f is equal to 1 over u plus 1 over v. So you may see 1 over 10 is equal to 1 over 30 plus 1 over v. So this that here is positive, of course. If it jump in another side, it will be taken away. So it will be 1 over v is equal to 1 over 10 minus 1 over 30. So 1 over v is equal to, we take the LCM between the 10 and the 30, which is 30. So 30 divided by 10, you get 3. 3 times 1, you get 3 here. 3. So 30 divided by 30, you get 1. 1 times 1, you get 1. So 3 minus 1, you get 2. Now 1 over v is equal to 2 over 30. So 1 over v is equal to 2 over 30. If you cross multiplication, finally we can get v is equal to 30 divided by 2. So finally we can get v is equal to 15 centimeters. So congratulations a lot for those who commented 15 centimeter, almost they are correct. So there is no doubt on that. Let's keep this momentum, and we are moving to the another question, which is question number 5 now. It is question number 5. Question number 5 say, an object is 15 centimeter from a concave mirror of the focal length of course, of the focal length. So there is no doubt on that. Let's keep this momentum. So the question number 5, an object is almost 15 centimeter from a concave mirror. An object, question number, it is question number 5 now. Question number 5, we say an object is 15 centimeter from a concave mirror, of focal length 30 centimeter. Find the image distance. Find the image distance. So this is our question, which is question number 5. There is no doubt on that. The question number 5, you may see yourself. An object is 15 centimeter from a concave mirror of the focal length almost 30 centimeter. Find the image distance. Find the image distance. 30 seconds to you to come out with the important answers based on this question number 5 now. Thanks for those who continue to comment and to come out with the important answers based on these important materials. We are trying to solve the concave mirror questions, so there is no doubt on that. To keep this kind of momentum. Thanks for those who continue to comment. There is no doubt on that. There is no doubt on that. Thanks for those who continue to comment. Soon we are going to confirm your answers, whether it is correct or not. We are going to confirm your answers, whether it is correct or not. So there is no doubt on that. Thanks for those who continue to comment. Now, let's do together this important question. So what is very, very important with this question is solution data given. We have given the object distance, which is 15 centimeter. And also you have given focal length is almost 30 centimeter. Now what will be the image distance? The one which is we are supposed to find. So we call the Miller formula. So from 1 over f is equal to 1 over u plus 1 over v. That is very, very important formula. So it will be now 1 over 30 1 over 30, 1 over 30, 1 over 30, 1 over 30 now is equal to 1 over 30, 1 over 30 is equal to 1 over 15 plus 1 over v. 1 over 15 plus 1 over v. So it will be now 1 over v is equal to 1 over 30 minus 1 over 15. Minus 1 over 15. So there is no doubt on that. There is no doubt on that. Now it will be 1 over v is equal to 30 here, of course. So there is no doubt on that. There is no doubt on that. There is no doubt on that. Now 30 here you can get, now it will be 30 divided by 30 divided by 30, you get 1. 1 times 1, get 1. So here divided by 15, it will be 2. 2 times 1, 2. So you may get 1 over v is equal to almost 1 minus 2 over 30. So if that is the case now, you can get now 1 over v is equal to negative 1 over 30. Negative 1 over 30. So if you close multiplication, finally, you can get now v is equal to negative 30 centimeter. So negative indicated that the image is visual. Negative indicated that the image is visual. So there is no doubt on that. Now the image distance, it will be 30 centimeter. The image distance now to be is almost 30 centimeters. So there is no doubt on that. There is no doubt on that. What is very, very important is to recall this formula. An object is 15 centimeter from a concave mirror of the focal length 30 centimeter. Find the image distance. So solution data given. We have given object distance 15 centimeter, and also have given focal length is almost 30 centimeter. What will be the image distance? From the formula, 1 over f is equal to 1 over u plus 1 over v. So it will be 1 over 30 is equal to 1 over 15 plus 1 over v. So it is very, very interesting. So this 1 over 15 jumping another side, it will be taken away. Now it will be 1 over v is equal to 1 over 30 minus 1 over 15. We find the LCM between 30 and 15. Now if we are going to find is equal to 30. So 30 divided by 30, get 1. 1 times 1 is equal to 1. 30 divided by 15 is equal to 2. 2 times 1 is equal to 2. So it will be 1 over v. Now 1 minus 2, get negative 1, of course. So it will be 1 over v is equal to negative 1 over 30. If you close multiplication, you can get v is equal to negative 30 centimeter. This negative, keep it on mind. Negative indicates the image is visual. The image now produced by this concave mirror is visual image. That's why you have negative image distance. So finally, the image distance is equal to 30 centimeter. Thanks for those who, and congratulations a lot for those who commented 30 centimeter. So this proves that they are more competent in physics. So there is no doubt on that. Let's keep this momentum to the question number 6 now. We have already did the almost 5 questions. So let's keep this momentum to question number 6. So there is no doubt on that. So let's continue with question number 7 now. It is question number 6. What is the magnifications? So question number 6 is, what is magnification? Question number 6 is, what is magnification? We want definition now of magnification. What is magnification? 30 seconds to you to tell us the definition of the magnifications. Now, thanks for those who continue to comment. The question number 6, what is magnification? So there is no doubt on that. There is no doubt on that. Question number 6, what is magnifications? So thanks for those who continue to comment. There is no doubt on that. What is magnifications? 30 seconds to you to come out to tell us the meaning of the magnification. Thanks for those who continue to comment. Soon we are going to confirm your answer whether it is correct or not. Yeah, the magnification, you say, this is the ratio of the image height to the object height. So this is the first definition. You can say magnification. Magnification is the ratio of image height to the object height, So that is the first meaning of the magnification. That is the first meaning of the magnifications. Or also you can say magnification. Also you can say magnification is the ratio of image distance to the object distance. Image distance to the object distance. So all are definitions of the magnifications. So there is no doubt on that. So definition, the first definition you can say there, magnification is the ratio of the image height to the object height. Or also you can say magnification, this is the ratio of the image distance to the object distance. All are answers. Congratulations a lot for those who comment the correct answer. There is no doubt on that. Thanks a lot. Let's keep this momentum. Let's keep this momentum to the question number 7 now. State the magnification formula. Question number 7. State the magnification formula. State the magnification formula. So this, of course, it is a question number. The question number 7 now. It is very, very important. Now, question number 7 there, you may see now, state the magnification formula. 30 seconds to you to come out with the correct answers. Thanks for those who continue to comment. There is no doubt on that. We are going to confirm soon whether your answers are correct or not. Congratulations a lot. The way you are participating today should be appreciated. Thanks for those who continue to comment. And soon we are going to confirm your answer, whether it is correct or not. Yeah, of course. Now let's see. Magnification has got different formulas, but the important one, which is so much famous, we have the first formula. Magnification is equal to image height over object height. That is the first formula. Or also you can say magnification is equal to image distance over object distance. Also, there is no problem on that. So congratulations a lot for those who comments, whether it is formula number 1 or formula number 2, there is no doubt you are more competent in physics. So these are very, very important formulas. If you want to find the magnification, you should take the image height over object height, or you can take image distance over object distance. There is no doubt on that, on how you can find this important magnification formula. Let's give this momentum to the question number 8 now. It is question number 8 now. It is question number 8, which say an object 2 centimeter high forms an image 6 centimeter high. Find the magnification. An object, this is question number 8. Question number 8 say an object 2 centimeter high forms an image of 6 centimeter high. Find the magnification. Find the magnification. So your turn 30 seconds you to come out with the important answers. What will be the correct answer of the magnification if you want to find that? Thanks for those who continue to comment. Congratulations a lot. You're trying to show me to show me that you are more competent in physics. So there is no doubt on that. Let's solve together these important materials. Thanks for those who continue to comment. Soon we are going to confirm your answer, whether it is correct or not. There is no doubt on that. 30 seconds you to come out with the important answers based on this important material. Remember, this is the topic of right on the subtopic of the concave mirror questions. So today we are trying to solve the concave mirror questions. Thanks for those who continue to comment. Now, let's do together. Let's do together solution data given. Solution data given. Solution data given. Solution data given. This question you have given object height. Object height is 2 centimeter, and also you have given image height, which is almost 6 centimeter. What is required is magnification. Magnification is equal to what? So it is very simple. We are supposed to recall that formula. We are supposed to record the magnification formula. Remember, we have two formulas. As you record the question number 7 here, you have this formula and also you have this formula. But this question, you need this formula, formula number 1. So when you record this, you can say from magnification is equal to image height over object height. Image height over object height. So it will be magnification is equal to 6 centimeter divided by 2 centimeter. You may see centimeter and centimeter cancel. Of course, magnification has no unit. So finally, we can get magnification is equal to 3. So there is no doubt on that. Thanks and congratulations a lot for those who comment 3. There is no doubt on that. They show that they are more competent in physics. What is very important in this question is to know and to identify data which you have been given. I've given object height, which is 2 centimeter, and also have given image height, which is 6 centimeter. What will be the magnification? So from the formula, we know magnification is equal to image height over object height. So magnification, it will be 6 centimeter divided by 2 centimeter. We see centimeter cancel out, and this proves that magnification has no unit. So magnification is equal to 3. Magnification is equal to 3. Congratulations a lot for those who commented 3. There is no doubt on that. They are more competent in physics. The way you are participating today should be appreciated. We are appreciating your cooperations of the lesson today. So let's give this momentum to the question number 9 now. Let's give this momentum to the question number 9. And the question number 9 tell us, question number 9 say why concave mirrors used as shaving mirror. Question number 9, why concave mirror why concave mirror are used as shaving mirror. Why concave mirror used as shaving mirror? That is very, very important questions. So 30 seconds to you to come out with the important answer. Thanks for those who continue to comment. There is no doubt on that. They are trying to tell us why concave mirror used as a shaving mirror. There is no problem with that. Thanks and congratulations. The way you are participating today should be appreciated. Thanks for those who continue to comment. There is no doubt on that to keep this and such kind of momentum. And such kind of momentum, there is no doubt on that. While you are dealing with these important materials, soon you are going to confirm your answers whether it is correct or not. So there is no doubt on that. Thanks for those who continue to comment. The way you are participating today should be appreciated. So now let's set the great reasons why the concave mirror uses a shaving mirror. We say concave mirror uses a shaving mirror because normally the concave mirror produces magnified uplight image. This is because it produce magnified uplight image. The concave mirror used as shaving mirror because normally it produces magnified uplight image. So a barber, there is no problem on how he or she can shave your hairs or your head. So there is no problem on that. The image of your head, it will be enough, large enough, so as there is no doubt on that. There is no doubt on that. So the gift reasons and major reasons and important reasons why concave mirror uses shaving mirror, because it produces magnified upright image. So let's keep this momentum and congratulations a lot for those who comment the correct answer. They are more competent in physics. So let's keep this momentum to the question number 10 now. There is no doubt on that. Let's keep this momentum to the question number 10. What is the SI unit of the focal length? Question number 10. The question number 10. What is the SI unit? What is the SI unit? Question number 10. What is SI unit of focal length? What is the SI unit of focal length? 30 seconds to you to come out with the important answers. On the question number 10 there, what is the SI unit of the focal length? What is the SI unit of the focal length? It is question number 10 now. What is the SI unit of the focal length? Thanks for those who continue to comment. There is no doubt on that. And this is very, very important materials. So there is no doubt on that. Thanks for those who continue to comment. Yeah, there is no doubt on that. What is very, very important is to show that we are understanding a lot of these important materials. Soon we are going to confirm your answers, if it is correct or not. So there is no doubt on that. Thanks for those who continue to comment. Now, the SI unit of the focal length, SI unit of focal length, SI unit of focal length is meter. is meter. Because the focal length is a part of the length. And we will know the SI unit of length is meter. So there is no doubt on that. Congratulations a lot for those who comment almost meter denoted by M there. So there is no doubt on that. Let's keep this momentum to the question number 11 now. Question number 11, why concave mirror used in solar cookers? Why concave mirror? Question number 11, why concave mirror? Why concave mirror used in solar cookers? In solar cookers. Why that? 30 seconds to you to come out with important answers. And thanks to those who continue to comment. Yeah, there is no doubt on that. There is no doubt on that. Thanks for those who continue to comment. Why concave mirror used in solar cookers? And soon you are going to confirm your answers whether it is correct or not. So there is no doubt on that. Thanks for those who continue to comment. So there is no problem with that. 30 seconds for you to come out with these important answers. Yeah, of course, we can explain now the reasons behind why the concave mirror used in solar cookers. The reason behind that, normally a concave mirror concentrates sunlight at one point. It is because concave mirror concentrates sunlight at one point, so it provides enough solar energy. It facilitates the solar cookers to have enough energy. The reason behind concave mirror, it concentrates the sunlight at one point. Now you may see normally the concave mirror, something like this, it tries to concentrate the sunlight at one point. So you may see all sunlight are concentrated at one point, at this point. If you concentrate at this point, at one point, it helps to have enough solar energy. Help to have enough solar energy. It helps to have enough solar energy because the concave mirror normally try to concentrate the sunlight at one point. So you may see now we are going to have enough energy. That's why the concave mirror you see in solar cookers. So let's keep this momentum, and congratulations a lot for those who comment the correct answer. There is no doubt on that. This proves that they are more competent in physics. So there is no doubt on that. Congratulations a lot. So let's keep this momentum to the question number 12 now. Which say, why concave mirror commonly used by dentists? Question number 12 now. Why concave mirror? Why concave mirror used commonly by dentists? Now 30 seconds to you to say and to tell us the correct answer now. Question number 12 there. Question number 12 there. Why concave mirror used commonly by dentists? Why dentists normally prefer to use this concave mirror in their activities? So 30 seconds to you to come out with these important materials. And thanks for those who continue to comment. There is no doubt on that. As soon we are going to confirm your answer whether it is correct or not. There is no doubt on that. Thanks for those who continue to comment. On the party and the question number 12, why concave mirror used commonly by dentists? So we are going to confirm your answer, whether it is correct or not. There is no doubt on that. Congratulations a lot for those who continue to comment. There is no doubt on that. There is no doubt on that. Now, the correct answer is that dentists normally prefer to use the concave mirror. The reason behind it, the same to the reasons of the question there, which say why the concave mirror uses a shaving mirror. So the reason behind it that normally concave mirror it is used by dentists in order to obtain a magnified image of the image. In order to obtain magnified image of teeth. In order to obtain the magnified image of teeth. That's why normally the dentists they are preferring to use the concave mirror in order to obtain a magnified image of teeth. In order to obtain the magnified image of teeth. So congratulations a lot for those who commented the correct answer. There is no doubt on that. Let's keep this momentum to the question number 13 now. It is question number 13 now. The question number 13 say, the question number 13 now, what is the relationship between the focal length and the radius of curvature? Question number 13 now. Question number 13 say what is the relationship between focal length and radius of curvature? What is the relationship between the focal length and the radius of curvature? 30 seconds you to come out with the correct answer on the question number 13 there. What is the relationship between focal length and the radius of curvature? Thanks for those who continue to comment. There is no doubt on you, and soon we are going to confirm your answer whether it is correct or not. There is no doubt. The way you are participating should be appreciated. Thanks for those who continue to comment. There is no doubt on that. We are going to confirm your answer soon, whether it is correct or not. 30 seconds to you as usual. After that, we are going to come with the correct answer. You're going to prove yourself if your answer is correct or not. So there is no doubt on that. Thanks for those who continue to comment. Soon we are going to check and to confirm your answer if it is correct or not. Now, the relationship between the radius of curvature and the focal length, we normally know that focal length is half radius of curvature. Is half the radius of curvature. There is no doubt on that. We say focal length is half the radius of curvature. Focal length is the half of the radius of curvature. We know that focal length is equal to radius of curvature divided by 2. So that is the relationship between the focal length and the radius of curvature. Congratulations a lot for those who commented the correct answer. You are more competent in physics. We will know the focal length is half the radius of curvature. F is equal to capital R over 2. So this is a relationship between the radius of curvature and the focal length. Congratulations a lot for those who commented the correct answer. You are more competent on physics. Keep it up. Excellent. There is no doubt on you. So let's keep this momentum to the question number. It will be question number 14 now. It will be question number 14 now. So let's keep this. Yeah, let's keep this momentum to continue the question number 14 now, which is stated about what happens when focal length increases. What happens when a focal length increases? What happens to the concave mirror when the focal length is very, very large? Increases. This is question number 14. This is question number 14. There is no doubt on that. Last time we covered the question number 13. So let's keep this momentum to the question number 14 now. What happens when focal length increases? So 30 seconds to you to come out with the correct answer. And thanks for those who continue to comment. There is no doubt on that. To show these important materials are very, very important. So there is no doubt on that. Thanks for those who continue to comment. As soon as we are going to confirm your answer, whether it is correct or not. And what happens when focal length increases? 30 seconds to you. What will be happening to the concave mirror if the focal length is large, very, very large? So there is no doubt on that. The question it is clear. Thanks for those who continue to comment. And soon you are going to confirm your answer whether it is correct or not. So there is no doubt on that. What happens when focal length increases? Now, congratulations a lot for those who try to comment. Now, the reasons behind that, if the focal length increases, the concave mirror will be less curved. That is the reason behind. We say the concave mirror will be less curved. So in order to have a good curved concave mirror, the focal length should be small. So if the focal length become very, very large, the concave mirror will be less curved. So it will be less curved. So if the focal length it will be here, it will be increased. So the concave mirror will become less curved. So that is the reason behind. So in order to have a good curved concave mirror, the focal length should be small. The focal length should be small. If the focal length will become large, the concave mirror will be less curved, will be less curved. So what happens when the focal length increases? We say the concave mirror will be less curved. So let's keep this momentum to the question number 15 now. To the question number 15 now, which say, what is the concave mirror also called? What is the concave mirror also called? That is question number 15. What is the concave mirror? What is the concave mirror also called? What is the concave mirror also called? What is another name of the concave mirror? That is very, very clear. So thanks. And this is question number 15 now. What is the concave mirror also called? 30 seconds to you to come out with the correct answer. There is no doubt on that. Thanks for those who continue to comment. Thanks for those who continue to comment. There is no doubt on that. So what is the concave mirror also called? Thanks for those who continue to comment. And soon you are going to confirm your answer, whether it is correct or not. So there is no doubt on that. Thanks for those who continue to comment. Now the correct answer that concave mirror also is called the converging mirror. The concave mirror also is called the converging mirror. Also called the converging mirror. The concave mirror also called the converging mirror. So that is another name of the concave mirror. Congratulations a lot for those who commented the correct answer. There is no doubt on them. They are trying to show that they are more competent in physics. So we say, what is the concave mirror also called? Also is called the converging mirror. So if you see the converging mirror is the same to the concave mirror, there is no doubt on that. Thanks for those who continue to comment and show that they are more competent in physics. Let's keep this momentum. We want to go to question number 16. It will be question number 16 now. It will be question number 16, which say that, question number 16, which say that, what is the magnification when image is half object? What is the magnification when image height is half the object height? Question number 16. What is magnification? What is the magnification? What is magnification when object height is half the when object height when image height is half the object height. When image height is half the object height, what will be the value of magnification? Question number 13. What will be the value of magnification, or what is the magnification when image height is half the object height? What will be the value of magnifications? So 30 seconds to you to come out with the important answers. based on this question number 16. What is the magnification when image height is the half the object height? Thanks for those who continue to comment. There is no doubt on them, and soon we are going to confirm your answer if it is correct or not. So there is no doubt on that. Soon we are going to confirm your answer whether it's correct or not. Thanks for those who continue to comment. 30 seconds for you to come out with these important answers. So there is no. So let's do together this question to check the value of the magnification. To check the value of the magnifications. Now we can say solution data given. Solution data given. Solution data given. So in this question, we have object height. So let's say object height is x, centimeter. Object height is x centimeter, and the image height is half the object height. So image height is half the object height. Is half the object height. What will be the magnification? We know magnification from the formula. Magnification is equal to image height over object height. Is equal to image height over object height. So you may see now magnification is equal to x over 2 centimeter over x centimeter. That is very, very important to note. That is very, very important to note. Now you may see centimeter and centimeter cancel. And here you are going to have magnification is equal to a half in bracket x over x. So you may see x and x will cancel. So magnification finally you are going to get a half. So that is very, very important answer, and congratulations a lot for those who commented the correct answer. There is no doubt on that. There is no doubt on that. What is very, very important is to know the solution data given. We have to let it any value, any letter which represented the value of the object height, say x centimeter, and the image height is half of the object height, so it will be x over 2 centimeter to be the magnification. We know magnification is equal to image height over object height. So magnification is equal to x over 2 centimeter divided by x centimeters. X centimeter cancel. So finally you're going to have magnification is equal to a half x over x. So x and x will cancel, and the final magnification is equal to a half. So there is no doubt on that. This is how we are going to do these important materials. Let's keep this momentum. Congratulations a lot. So today we are going to end here to the question number 16. On next time we're going to keep this momentum to move on the question 17 onwards. So there is no doubt on that. Congratulations a lot. Today you provided a great participations. Don't forget to like, to comment, to share to other these important materials, as well as to subscribe our channel. Thanks.